page from the back table. Always try to make sure that you glance at the back table when you come in. Likely, if there's anything to be handed out for the day, it'll be there just to make life easy. You're never too old for a reference sheet. So this multiplication table can go wherever you want. I 3-hole punched it so it can clip in your binder. Or you can cut it and glue or tape it into your math journal if you prefer. That is up to you if you want to glue or tape it in your math journal. Before we dive into the lesson, does anybody have any questions from the homework from over the weekend? I will be collecting your math journals at some point this week, so please make sure that we're up to date on homework. Of course, if I collect them today, I would not expect Friday's homework to necessarily be done, but I would be checking everything up to that. I give you 2 business days, 2 class days to get stuff done. So today's homework, the 114, 118, first time I would expect to have that done for everybody's Wednesday. It'd be great if you have it done by tomorrow, but have it done by Wednesday. I give you 2 business days. Questions on changing the portions? We want to change things to out of 100 because out of 100 relates to percent. Thank you. So when we write these as a percent, we write them each as out of 100. Please make sure we're labeling. You can check your math journal right now if you want. 105 in your homework should have parts A, B, C, and they should be labeled. Question 106 should have parts A, B, C. They should be labeled. Please make sure we're labeling things as we go. If not, try to fix your homework at some point. 107 should have parts A, B, C. Please make sure they're labeled. Any questions? Grant's just giving me the stare down. Just locked in, ready to go. All right, so multiplication table. Put this somewhere. Reference it whenever you need. Some of us are really good at our multiplication facts. Some of us don't like memorizing things. So, yeah, some of them just sink into your memory just because. Like, you can't do anything to stop it. Other ones is tough. Like, 12 times 12 I've always thought was sweet. Because 1, 2, 1, 2 makes 1, 4, 4. Just in my head, I thought it was sweet. 13 times 13, what is that? 1, 6, 9. 1, 3, 1, 3 makes 1, 6, 9. I thought that was super cool. So stick that somewhere. Check out the cool ones. Chat with me if you want to about any of the cool patterns you see. We're going to dive into fraction addition. So remember, we want our toolkit open. So please open our toolkits. Mine sank down to the bottom line. If you have run out of space over here on page 11 or page 10, we're going to actually get to more of page 11, so I would not necessarily fill up all of page 11. Remember, there's the pages at the front of the book, but reference back to your notes right here if you need, like your math notes. So we see Justin's working on a problem. So the first thing your group is going to do is dive into trying to help Justin. Alan and Grant, if you want to stay as a pair, you can. Otherwise, split up to the 2, 3 groups here. Today's not super heavy, so you could probably make it through as just a pair if you want. If you want to split to the other 3s, you can. Let's just start working through, and let's see how far we can get. Give you guys about 10 minutes or so, and then I'll bring us back together and see where we are. How's that? I will blow this up a little bit more probably, but go ahead and dive in. Group roles can be the same unless you want to change. So if anybody really wants to change, have that conversation very quickly. But then we want to focus up on 108. Oh, hold up. I wasn't here for this class on Friday. Who can explain to me what the giant 1 is and why we use it? Aubrey.
It's a whole number.
What do you mean?
A whole number is, so you had 6. So you would have you'd have like 1.
Well, you really have 6 of the 6 pieces. So if you had 6 sixths, a way to represent that would be if I had my pie, and there are 6 pieces. Now these should really all be the same size. 1, 2, 3, 4, 5, 6. Sorry that I didn't cut very well. And I have all of them. I have the whole thing. So remember back to Friday's work with the giant one, since I wasn't here, we're going to utilize the giant one to help us as we go through this lesson. Okay, so I'll give you about 10 minutes. Dive in. So, I think some people are having trouble analyzing what A is asking. It's asking, could you name it as a single fraction? Can you take two fractions, put them together, and express it as a single fraction, just number over number? Then it's asking a separate question, would it be 2/3? Is that the answer? So, could I express this as a single fraction? Is this possible, yes or no? And then, is it 2/3? And then move on to B and C and D. You can draw a picture in your notes too if that's helpful. The graph paper should help you. one of the geometrically minded people, another question you can ask yourself is, how can I figure out what's not shaded? Take about a minute or two, wrap up 108 with your group if you haven't yet, and then I will use cards to figure out who we're going to talk with first. These are really slippery. I might remake note cards like I used to. I like that they're laminated, but they're so slippery. Yeah. They're just so slippery. Good for when I spill my coffee. So, again, feel free to ignore me, but please respect whoever's talking. Allie, when we look at A, it's hard for me to picture this all. Can we, when we add a fraction with a fraction, explain those? Can we write it as a single fraction? No. What we always have to support. So, yes or no needs justification behind it. So what do you think? The amount that is now shaded, can we represent that with a single fraction? And I know I put not shaded up here, but the amount that is shaded. Wait, I'm confused. You said no, now you say yes. So, yes, you don't have to know what it is yet, but why are you saying yes? Because we need a because. And in your notes that you take for math, guys, I don't care if you write shorthand. I would actually encourage you to write shorthand. So BC can be used for because. Capital B, capital C is, dating. But BC, little bc, because. So, Allie, do you know why we're able to? Sorry, what? Yeah, so you get the sum of one fraction. Now, that's really mathy. When I'm thinking about this, I just think I have a portion and another portion, and when I put them together, I just have a bigger portion. So I'm just going to say it's still a portion. I don't care what you have written here. Allie said it sums to a fraction. Well, my answer, it's still a portion. I know I can still use a fraction to represent it. Might be an awkwardly sized portion. It's bigger than it was before. But imagine having a third of a pizza and half a pizza. I can put it together and I just have some pizza. I don't have to be able to count it necessarily. Then, blank card, Nathan, can we represent it, is it 2/3? No. Now, do you know what it is, or do you just know that it's not 2/3? So Nathan says he thinks this is 5/6. So I should probably change color to talk about something else. So you think these add up to be 5/6. Now, why do you think that? Did you work through part B? Yeah? So let's go ahead and work through part B to see if you are correct. So our giant ones here, what did you use for your giant ones in this situation? How am I going to go through the giant one to get a 6 in the denominator? So 3 times what gives me 6? 2. So we need a 2 in the denominator, which tells me I have a 2 in the numerator. So, straight across here, I have 2 6 now, plus, well, again, through the denominator, what do I use? 3/3. So I get 2 6 plus 3 6. Is Nathan right with his 5/6? Absolutely correct. Please make sure that you have that conversion using the giant one. I would advise to use the giant one, like box around your ones, even if you don't like make it pretty like a 1. Mr. Smith is really good at making the box letters or numbers, by the way, if you need some help. But I would just make a note, make a box, make something so you know it's a giant one. So we answered C, thank you to Nathan. And then why? Why can't we rewrite it with 2/3? So Matt, what do you think? Why? Well, we know it's not 2/3, but why not? Why didn't we use thirds? You know? Why we can't use thirds? Anybody? It's weird to articulate, Alex. What do you mean it wouldn't be equal? Yeah, try to use a different word. I agree with you, but so the pieces aren't. Yeah, so think about your pizza, right? So imagine these are rectangular pizzas. You get a long strip that's a third, and then you get a big old strip that's a half. These aren't the same sizes. So even though I can now say I have 2 pieces, they're not the same size. Anyone see what I did right up here? I cut them again. So instead of using the size that they gave me, can you imagine if I could pick up this pizza and rotate it and have the line going straight across the middle? I could then cut this exactly the same with a line straight across the middle. Then the cuts that I would need to match would be the 2, cutting it into the thirds. So I just put those sideways here, 6 pieces here, 6 pieces here, 3 shaded, 2 shaded, 5, 6. Any questions? Move on one minute.
Students were adding the fractions 1 to a specified code score. They each found a different common denominator. It was good. Would you get it?
Well, do you need metric or yard?
Meter. Metric. As many as you can.
Yeah, a lot of mine walked away with, this is all inches, with Rube Goldberg stuff. Somebody has a box. There is, they might have been Stephanie's room.
Yeah, those are the ones. This is
Yeah, that's about all I got, I think. I might have one in my outfit. Wait. Here's another box that we have. These I think are a bunch of yard ones.
Yeah, we have a bunch of yardsticks that I think they came from
a fair. These all came from the camp. These are all just inches. And that treaty of the meter.
I was gonna go over and get some from.
If we had switched, that wouldn't be a question.
I know.
I might have a couple back here. I got one more
by like 20. Couldn't be that much.
Most of those are inches, though. I think.
All right. Thank you.
You are welcome. Who needs more time to figure out who's right? Who needs more time to figure out who's right? All right. Try to get that in the next minute or two. Just check with what did they do to those initial fractions to get to line 2. So we're going to call this from the start line to line 2. From the start line to line 2. Ella, who's wrong? Give me one person that's wrong.
But, like, nobody's wrong. Just, like, Armando has the least common denominator. Like, neither of them are wrong. Just, Armando has the least common denominator.
So you're saying no one's wrong, but I see a denominator of 12, denominator 24, and denominator 48. So I guess if no one's wrong, who did it best?
Armando did it best because he has it's rounded like down the nose.
Now here's the funny thing. That's best for you, right? So that's an opinion word, right? Best is one of those opinion words. Interesting thing about like American, like best toothpaste, best this week. There's actually laws in Europe you can't just say things. I would actually argue that for some of you guys, you'd say Lily did it best. Who could make the argument why we could say Lily did it the best? I don't like, how would you pronounce that? Jose? It's an interesting spelling of Jose. Normally it's J-O-S and
I think it's actually Josue.
Josue, yeah, that'd be
I had a
sweet.
student named Josue.
Okay. I don't really like this method. This is more complicated than it needs to be. But Lily's method's really efficient. Can anyone spot what Lily did to get her denominators?
They just multiply the denominators by each other.
They just multiplied the denominators by each other. My 4, if I multiply by 12, and my 12, if I multiply by 4, I know they'll make the same number. Right? 4 times 12 and 12 times 4. That is the commutative property. Order doesn't matter. We can commute, change location. So if I do times 12 and 12 here, boom, times 4 and 4 here, boom, then I get my answer. Then I could reduce it. Now, what Armando does that Lily didn't was he did it in the most efficient way. Like what Ella said, the least common denominator is 12. Just multiplies up and gets 12. But if you aren't certain, just use the other denominator. So take a moment, write that out in your math journal or in your toolkit, wherever you're taking notes right now. Which one you would choose and why? Which route you would take? Would you take the Lily, the Armando, or the Josue route? Then once you take a second to write that down, go on ahead and move on. Exactly like Alice said, no one was wrong. There's just better or worse depending on your brain, depending on what you choose. So Marvin, when you get down to part C and it asks you to do 3/10 times 1 or plus 1/5, what did you think of to do to get them to have a common denominator? Didn't get there yet? Okay. So keep working. You're good. If you need to use your multiplication table, Annika, do you know what our common denominator can be when we're working with 5 and 10? We have a lot of options, so you can choose, but depending on your brain, depends what you think is better. 10! 10 will work. So what do I need to multiply 3/10 by to get a denominator of 10? It's already there. So Annika's going the efficient route. I'm going to leave this how it is. So if you really want to show the addition, you could show that we're going to leave it. 1/1 we know is 1. You don't need to write that. That's completely unimportant. But what's really important is getting the 5 to turn into a 10. What do I multiply 5 by to get it into a 10, Annika? 2. So I do 2/2. Make that giant 1 if you're more artsy than I am. So now 3/10 doesn't change. So I still have 3/10. My 1/5 becomes 2/10. And we get, anybody? 5, right? Or, I mean, tell me if I'm wrong. Which then, I know 5 out of 10 reduces to a half. And I can get there through division by 5 on bottom, division by 5 on top. Any questions on part C of that one? Please, as a group, move on to 109. Or, sorry, 110. My bad, a question behind. You guys are sharing books, you can put yours on the floor. Yeah, don't clutter up your desk. If you're sharing books, don't feel like every single person needs to have a book out. If you're sharing books, that's fine. So I like working vertically, but if we have to pull it off and talk about why the numbers are changing, I do it because yeah, if they get it and they don't have to show it, if they totally get it, they don't show it.
Yeah, for a certain kid, it might be really helpful.
Yeah. Couple more minutes and I'll bring us back together here. Alright, I want to see if we can go ahead and start chatting about this. I'll take volunteers. Do 6 and 8 have a common factor that's not 48? Do 6 and 8. What do you think, Grant?
24.
24. If I go down the 6 column, I can find a 24. Down the 8 column, I can find a 24. Now, can I use 48 just fine? Yeah. Then I'll have some reducing to do at the end. Maybe. But if I use 24, I might not have any reducing to do. And there are no common factors less than that. So we can do the same thing when dealing with other denominator values, looking for common factors. So between 4 and 10, for View's next problem, 4 and 10, what's going to be the lowest common multiple? Least common multiple. Because as I go up, I'm multiplying. Sorry, I think I said factor a second ago. I'm multiplying as I go up. So these are my multiples. Okay, 20. Because if I go down my 4 column, I can find a 20. If I go down my 10 column, I can quickly find a 20. So what is my giant one here to get my 4 to a 20? 5 over 5. Be careful. Make sure we say both. And multiply my 7/10 by. Go ahead, Kate. What did I multiply 10 by? 2. So 2 over 2. So then my new values, and if you don't have this set up at all on your paper, somehow show what we're doing. Even if you just like show it off to the side or written small, you don't have to do the giant ones if you get the concept. But it would be great to go ahead and do it. So we get 25 20ths. Because it started improper, it's going to stay improper. Plus 14 20ths. What's our final sum? Yeah. 39 20ths. Which is almost 2. Sorry, my 3 has a weird dot in it. 39 20ths. Now I'm going to skip on over really quickly so we can see who's really turned on and getting this really, really well. Who thinks you're really awake this morning? You got it. You're like going. You're rocking it. Yeah? All right, so we're going to skip to 112 really quick. No, we probably won't. Unless you want to leave space for 111, you don't have to. 1/4 and 5/6. When we think about 4 and 6 as my denominator. We're just going to write some examples down here. So we're going to work fast. We're not going to show all of the work. If you then need to come ask questions later, come see me and ask questions later. Grant, what's our common denominator between 4 and 6? 12 is the least. So what do I have to multiply 1 and 4 by? What do I multiply 4 by to get to 12? So I have to multiply by 3, so I get 3 twelfths. What do I multiply my 5 sixths by? 2, so I multiply by 2 and 2, so I get 10 twelfths, and we will get 13 twelfths. These values that I'm jotting down right here are what we're multiplying by. I still got a couple minutes. I don't know why they're releasing so early. 7 and 3. Work up the multiples. 3, 6, 9, 12, 15. Work my way up. Least common multiple for 7 and 3 is the multiple of each other. So here my least common multiple is 21. So I'm just going to multiply my 2 sevenths by 3 and 3, giving me 6 21sts. I then multiply by 7 and 7 and get 14 21sts, not 24ths. And we get 20. I want to give you a little bit of time to pack up. So C and D, I would advise that you try, but we will probably check homework. So if you want the best advantage, try to do this tonight. We will check homework to start class tomorrow. Not like check if it's done, but like check your answers. See if you have any questions. Well, that's when we would. So when I asked for Audrey this morning if anybody had issues on the homework, did you have any issues on the homework over the weekend? So why didn't you speak up? Because I was asking for questions.